Hello everyone! Today we're going over question 1 from paper 2 of the sample assessment material for Edexcel for the Pure Maths, the GCSE level. Alright, so this question is about geometric series with an e to the something. Now, the nth term of a geometric series is 3 times e to the 1 minus 2nth power. Find the sum to infinity of this series. Give your answer in the form ae over e to the power of b minus 1, where a and b are integers to be found. So we need to keep in mind that they want it in this form. Alright, so we know that the sum to infinity formula, so the sum of a geometric series, so where a is the first term, r is the common ratio, and n is the term number, because it's a times r to the power of n, and then of course n starts at 1, it goes to infinity. What is this equal to? Well, it's equal to a over 1 minus r. This is the magic formula for the sum to infinity of any geometric series. So first, let's try and find a. A is t1, tn is 3 times e to the power of 1 minus 2n, so t1 is 3 times e to the power of 1 minus 2, or 3 times e to the power of negative 1, or 3 over e. And then, so a is 3 over e, or 3 times e to the minus 1th power. And now if we find term 2 and divide by term 1, we will find the common ratio. So t2 over t1 is equal to r. Term 2 is 3 times e to the 1 minus 4, which is equal to 3 times e to the negative 3. And so you can also say this is 3 over e cubed. Either way, you get term 2 is 3 over e cubed, so therefore term 2 over term 1 is 3 times e to the minus 3. And this is a comma, by the way, not an r1. This is just a comma. 3 times e to the power of minus 3 over 3 times e to the power of minus 1. So first we cancel out the 3's. And then if this is minus 1, we can also cancel out a minus 1 from here. So this is e to the minus 2 power, because e to the minus 3 is really e to the minus 2 times e to the minus 1, and we are just cancelling out the minus 1 from both sides. Alright, so we are left with the common ratio r is e to the negative 2. So our answer for a over 1 minus r this is 3 e to the negative 1 over 1 minus e to the negative 2. Now, it wants us to have e to the something power minus 1. And it also wants the e term on top to be e to the power of 1, or just an e. So, what we will do is we will multiply both the numerator and the denominator by e squared. Why is this? Because if we want e to the negative 1 to go to e to the 1, and that e to the minus 2 to go to 1, which is e to the 0, then we will need to multiply everything by e to the power of 2. And since we're multiplying both the numerator and the denominator by e squared, the value of this fraction remains the same. So we will get after multiplying by e squared, 3e over e squared minus 1. Now, we have given our answer in the form 3e, or an integer a times e, over e to the power of an integer b over e squared minus 1. Alright, let's go to the mark scheme and see if we are correct. This question was quite interesting and straightforward, so I hope you had not too much trouble following it. So, the first term is 3 times e to the minus 1. The common ratio is e to the minus 2. You have the sum to infinity is 3 e to the minus 1 over 1 minus e to the minus 2. And then we multiplied both sides by e squared to get 3e over e squared minus 1. Alright, that's a tick for us. 5 marks. Have a great Chinese New Year, and thank you for watching.